Hello everyone, welcome back to my YouTube channel. This is part... Please be quiet. Welcome back to my YouTube channel. This is the part number 5. Today we are going to speak about the transform method for the sub-bassine. The transform method is the actual surface runoff calculation within a sub-bassine. There are 9 different possibilities. All those transform methods based on different assumptions. In the theory, in the manual of Hec-Hms, you might find all the explanation of all the methods. We got the excess rainfall with the SCS curve number method, and now we transform the excess rainfall to direct runoff hydrograph using the SCS unit hydrograph transform method. This method is designed for a single storm event. In order to select the right transform method, and in case you want to use the same transform method for the whole sub-bassine, go on Tools, Program Setting, Default. Here you can select the transform method that you wish. In this case, we are going to select SCS unit hydrograph. Doing like that, you can see that by each sub-bassine, when you click on the hydrograph, you have it already selected, SCS unit hydrograph. And you can see the SCS unit hydrograph requests 2 types of parameters. The first one is the graph type. Per default, you have the graph type 484, and then we have the lag time. The graph type tries to reflect the slope of your sub-bassine. Typically, if your sub-bassine is as flat, then you should use a lower PRF, smaller than 100. If your sub-bassine is steep, you might increase your graph type going up to 600. And we have the lag time. The lag time tries to express the time gap between the maximum rainfall to the peak of the hydrograph. There is an empirical method to calculate the lag time based on the time of concentration. The time of concentration is the time taken by a rainfall drop to travel from the farthest point into the watershed to the outlet. Here is the equation, and the lag time is 0.6 part of this time of concentration. Please be aware to consider the lag time in hours. The time of concentration is built by the flow length in feet, which is a parameter that you can take directly from your Hec-Hms. The average watershed land slope, again a parameter that you can take directly from Hec-Hms. And finally, the maximum potential retention in inch, which is an equation that is based on the curve number that we have seen previously. Let's develop the lag time equation. At this point, we can start producing the missing value. We open the Excel file that contains the CN number, and at the same time we can open our Hec-Hms. From Hec-Hms we will take all the parameters of the sub-bassine, parameters characteristics of bassine. Here, if you don't have the value, just recompute everything. Be sure that you have displayed everything alphabetically. For the Excel, open a new page. Here you write the number of the sub-bassine that you can take from Hec-Hms. That's this one. You copy it, you paste it. You can take the length in kilometer, that's this one. You copy it, paste it. You can take the slope of the sub-bassine, which is this one. You can copy it, you can paste it. You can take the curve number from the previous page. You can calculate S. S, we know that it is 1000 divided curve number minus 10. We can have the slope in percent. It is the slope multiplied 100. We can have the length in feet. It's the length in kilometer multiplied 3280,84. We have to calculate the time of concentration. The time of concentration is the length in feet. elevated 0.8 multiplied by s plus 1 all elevated 0.7 all divided by 1140 multiplied sloping percent. Now the lag time is 0.6 time the time of concentration. Finally the lag time in minutes, lag time times 60 times 60. So we have 24 minutes. Here we might have 24 minutes. Here we have 2 minutes. Sub-basin 15 must be a very small one, while sub-basin 1 must be a big one. Let's have a look. Sub-basin 50 is this one, actually a very small sub-basin, and sub-basin 1 is this one, actually a very big sub-basin. So it seems to be correct. At this point we have to insert the lag time into Hec-Hms. We go into Excel file, we copy the parameter for the lag time, we go into Hec-Hms. Under parameter and transform, you can see the CS unit radiograph is activated. Here again we select all sub-basin. Once again verify that you have displayed alphabetically, and then you can pass your parameter and click on apply, close and save. Now you can see that each sub-basin has received the lag time and as well the curve number. That's all for part 5. Thanks for listening.